Right, esterification reactions are the reactions between an alcohol and a carboxylic acid. So alcohols react with the carboxylic acid to form esters. Remember that in ester, you have a chain of carbons, and then you have the double bonded oxygen, and then an oxygen that's also within the chain. This side, without the double bond, is considered your side group, and so you would name that as a prefix, and then the side with the double bonded oxygen is considered your root chain of carbons for naming. It's an equilibrium reaction. It's catalyzed by concentrated sulfuric acid. Esters have a low boiling point, so they can be separated by the use of distillation. Esters have a distinct smell, so a lot of times they're used to be detected in water. They're insoluble, and they'll actually form a layer on top of the water. So here is a reaction. You have ethanol reacting with ethanoic acid. So the hydrogen from the hydroxyl group bonds to the hydroxyl group of the carboxylic acid to form your water, which is why it's a condensation reaction. And then to complete the chain, the oxygen then bonds itself to the carbon that lost the OH group. And so we have ethyl ethanoate and water to finish that out. Ethyl ethanoate smells of sweet pear, or it has a sweet smell to it. Some people say it smells like pears. It's used in glue and nail polish removers. It's used to decaffeinate teas and coffees. And then here's a list of other esters and their fragrances. Hopefully after winter break, we will be looking at some of these in class. So let's work 2 examples out to see if we can do this. I'm going to draw out the structure so I can show you what's happening. So methanoic acid, meth means you have 1 carbon, and then anoic acid means it's a carboxylic acid, so we have the double bonded oxygen and then the OH group. Ethanol, eth means 2 carbons, and then it has the hydroxyl group on it as well, and then some hydrogens. And so the hydrogen, the hydroxyl group here is going to bond with the hydrogen over here, and so this is what's forming the water, and so that leaves us with this scenario once the water has left. And so we're just going to continue this bond right here, forming our ester. And so as a product, we would have our ester maybe drawn like that, and then you can fill in with some hydrogens, and then you have your water. So to name this, again, we're going to name this part of it, the part that's coming off of the oxygen, as a side group. So that would be ethyl. And then the side that has the double bonded oxygen is going to be our root. There's only 1 carbon there, so it's meth. And then esters end in NO8. Okay, let's try that again here with butanoic acid. So but, remember, means 4. And then anoic acid, so we have our double bonded oxygen and our hydroxyl group. Methanol, so 1 carbon, and we have our hydroxyl group. And we can add in our hydrogens. And so this hydroxyl group is going to bond with that hydrogen to form our water, which then would give us this connection right here for the ester. And so we have as our product our 4 carbons, then our oxygen, and then our single carbon on this side. So to name this, again, we name the side that has, or the side with just the oxygen in between, so this is methyl, and then name the side that has the double bonded oxygen, so 1, 2, 3, 4, that's but. NO8, whoops, OATE. And then the other product would be water.